Is this thing on? Oh, okay. Hey, everyone. So I'm here going through the notes for IVT, Intermediate Value Theorem. We started talking about it in class. I got cut off at the end there. So I'm going to go through this note sheet, or at least most of it, and make sure that you guys know how to do your homework for tonight. Okay? So just make sure you watch this video. Please tell people to watch it if they don't know. And yeah, let's do this thing. All right. Intermediate value theorem we discussed in class. If you have a continuous function, on a closed interval, that just means from like two x values. So in this case, it's from here, a, up to b. And you can see I have a continuous function. There's no breaks in it. There's no discontinuities. There's no jump or infinite or whatever going on in between. Then what this theorem is saying is that this function will hit, like it guarantees, will hit everything in between. We'll hit every y value in between, right? So it's like this x, like this piece will guarantee this piece. I'll do it in a different color. Will guarantee this red height, meaning like, okay, so meaning like if this was if this was like let's say my x values were like 1 to like, I don't know, 1 to like, that's 1 and that's like 7, and these height values were like 2 to like 10. So that means if I know 2 points, right, if I know 2 points, that and I know that the inside piece is continuous. That's important. They have to say that it's continuous. Then all of the y values will exist. So I know 3 exists. I know 3 exists, 4 exists, 5, 6, 7, 8, 9, 10. I know all of those values exist somewhere on this line for some x value. Okay, so let's see how to use this thing a little bit more in depth here. All right, discard, and let's move down. So these are some velocities for a bike that's riding on a straight road. So it means at a certain time it's traveling at this sort of speed in a certain direction, right? So let's see if we can answer some of these questions. So it's saying from 0 to 20. So from 0 all the way to 20. So I'm looking at this number 1. Must there be a time where the velocity is 2.5? Okay, so we are using the IVT, so we need to identify first, yes, this is continuous on this interval, meaning it's going to be a connected graph from 0 to 20, and that means, because by IVT, all of the y values will be hit. That means the lowest y value that exists and the highest y value that exists will be hit. So like, I know it's kind of hard to picture. So why don't we just like sketch this? Why don't we sketch what this, like plot these points and see what they look like. So at time 0, the velocity is 3.3. Let's say it's there. This is 3.3 and the velocity is 0. Okay. And then at 5, the velocity is 4.2, which is, I don't know, let's say it's there. At 7, velocity is 2.7, which dips back down below here. At 9, I should have made this graph a little bit more detailed. Sorry, 2.3. So it's like it goes a little bit below. 14, it is 3.8, which is below 4.2. And then 20, which is 4.6, which is a little higher. So these points are going to be connected. How will they be connected? I don't know, but I know for sure that all of the heights, like the highest height that exists and the lowest height that exists, everything in between has to exist. Right? So if I kind of identify that, right? The highest point in this case was, what was it? I think it's 4.6. And then the lowest point that exists is, according to the chart, I think it's 2.3. 2.3. So I know anything between 2.3 and 4.6 will exist by the IVT. So 2.5, where does that fall? Well, that falls in between 2.3 and 4.6. So what does this mean? The answer is yes, it will exist. How do I know? Because it says to justify your answer. How do I know? You can just straight up say by IVT. Problems are that easy. Okay, let's look at number 2. Same scenario, same picture, same velocities, right? Must there be a time where the velocity is 5 from 0 to 20? Well, our highest velocity was 4.6, and since 5 is above that, let's say 5 is there, we don't know. We don't know if the velocities will hit after 20 or before 0, and we know for a fact it does not hit, or we don't know that it hits at 5. That's why the phrasing of the question says must, right? Like it could, but it also could not. We don't know. So we can say no, because the highest value that exists is 4.6 by IVT. So easy, I know. And lastly, what is the least number of times where v of t is exactly 4 meters per second? Okay. So what this one is saying is, can you guarantee that 4 will be hit, like a velocity of 4 will be hit? Well, what does that mean? That means I need to look closely between every interval. And see if 4 can be achieved within each sub-interval. Like, so for example, from between the first 2 points, between 3.3 to 4.2, do we cross 4 at all? Yes, we do, right? Because 4 is in between 3.3 and 4.2. So yeah, that's 1. It's going to hit 4 once, at least. Then we look at the next interval. From 4.2 to 2.7, will you cross 4? The answer is yes. On the next interval, from 2.7 to 2.3, will you cross 4? You don't know, so we say no, just to be sure. From 2.3 up to 3.8, do you hit 4? No. Then what about from 3.8 to 4.6? This one is yes. So to answer this question, the least number of times has to be 3. 3 times where v of t equals 4. In fact, you know what? I'm going to be a little bit more specific, and I hope you guys are this specific too when you answer these questions. I'm going to say at least. Okay, because it could be more, but you know for sure it has to at least hit 3 times. Okay, so at this point, you should be able to do these problems. If you want to stick around, you can. So you can stop the video now and just do your homework from here. But I'm going to do another example just in case people need to see some more. Okay, so yeah, try the problems on your own. See what you get. So here we go. Let's do. Oh, this one's fun. Okay, so let's see here. I have a function, a table of values, right? And they define a new function called h of x, okay? And I know it looks kind of scary because there's a lot of letters and stuff going on, but all you do is just you have to follow it well. You just have to follow where the x goes. What do I mean by that? So if the question is asking about h, we're probably going to need to add, to put in a h of x function in here. Okay, so meaning we can come up with some h of x values by following this definition. Watch. So I start with x equals 1 because they only give us 4 x values. So of course I have to start with 1. I plug 1 into f and I get 2. That's what this table means, right? If I plug 1 into f, I get 2, and then if I plug 1 into g, I get 6, right? So that's how you read the chart. But if I'm asking for h of 1, I'm just going to do it right here. H of 1, using the definition up here, I get g of f of 1 minus 3. And if you guys remember, you just work from the inside out. So for this one, what did we say f of 1 was? Well, f of 1 is 2. Okay, so then I simplify this. Okay, now I got to figure out what is g of 2. I just use the chart. 2 is 9 for g. So this becomes 9 minus 3. And look at that. I get 6. So h of 1 is 6. I'll do another one. H of 2. So that means I'm looking for g of f of 2 minus 3. All right, I got to figure out what is f of 2. F of 2 is 3, according to the chart. All right, so this becomes 3. Oh, well, that means now I'm looking for g of 3. You see I'm like working from the inside out? G of 3 gets me 10. 10 minus 3 is 7. So that means the next one is 7. Try and get the next two by yourself. So pause the video right now, pause it, and then you better pause it, and then try and figure out the 3 and 4. I'm going to show the answers in the next second. Okay, so you should have gotten -4 for the next one and then 3 for the last one. And now that we have a function, right, we can answer the question. Must there be a value in between 1 and 3? So we're looking in between 1 and 3 where the height will hit -2. So if you're not sure, just try to draw it out. I'm going to draw out a quick little graph here. Here's 1, here's 2, here's 3. And h of x is going to look like 1, 6, 1, 7, which is somewhere up there. And I'm sorry, 2, 7, and then 3, -4, which is like somewhere down there. Right? So if that's the graph of h, it's asking, must there be a value where h of r is -2? Well, if this is -4 and -2 falls somewhere here, yeah, it's going to be like somewhere over there. So we say yes by IVT. Okay? Hopefully this helped. If you guys want another video, by all means, just ask. And yeah, let me know what you guys think, all right? All right.